let's say in your research work, you got numbers like 20, 30, and 40. Now you have seen there are deviations in this number. The number deviated from 20 to 30 and from 30 to 40. Then the question is, how can you calculate the standard deviation? How do you know the standard, the average deviation in this your research work? So in this video, you will learn what standard deviation is all about, the formulas, and some examples. Now, what is standard deviation? Standard deviation measures how far a set of data is spread out in relation to its mean. Now, let's take for example, we have a set of data like 3, 4, 5, 6, and 7. And in another set of data, we have 3, 5, 7, 9, and 11. Okay. Now, if you see the first set here, the set of data follows normal numbering pattern, which are from 3, 4, 5, 6, and 7. Okay. So we can say the deviation here is very, very low. In fact, there's no deviation here, it's low. And then when you come to the second set of data, we have something like 3, and the number deviated from 3 to 5, and from 5 to 7, okay, from 7 to 9, from 9 to 11. So there's a deviation in this set of data. So we can say that here the deviation is high. Okay, so in calculating standard deviation, there are two formulas you need to be aware of. One of the formula is population standard deviation, which is represented by sigma. Okay. Now, the formula for population standard deviation is summation of individual population value. Okay, the example we gave earlier, we have 3, 4, 5, 6, and 7. Okay, and then so individual, which are this individual. When we say individual, we're talking about 3, 4, 5, 6 individually. The X bar represent individual. Okay, and then the population average, which is represented by mu. Square root, you square everything, divided by n. N is total number of population. Okay. Now we have, how many numbers of population do we have here? We have 1, 2, 3, 4, 5. So these are the total number of population. And another formula you need to be aware of is sample standard deviation. The both formulas are the same. The only difference in the formulas is this one has n minus 1, and this one have only n. Okay, that is the only difference between the both. Now the x bar here is sample average, while in population standard deviation, the x bar is represented by a mu. So if you ask me, the thing, they are the same. You just the n minus 1 that is different. And so you should know the one you are working on. If you are working on population, you should use population formula. And if you are working on sample, you should use sample formula. Now let's prove our point. Okay, remember we said here there is low deviation here, and here there is high. Now let's solve the two examples and prove our point. Now we have said, I'm using a population standard deviation. Now we have said xi represent individual number. Then let's work the first one. The individual numbers, we have 3, 4, 5, 6, and 7. And then the mu, okay? How do we get the mu? Look at how we get our mu. 3 plus 4 plus 5 plus 6 plus 7 divided by 5. Why I'm using 5 is because the number of population is 5 here. 1, 2, 3, 4, 5. Divided by 5. So let's use our calculator. 3 plus 4 plus 5 plus 6 and plus 7. So we have our answer equals to 5. 5 is our mu. So we fill our mu 5 here. 5, 5, 5, 5. And then the next one here is our x1, which are our individual population, divided minus from our population mu. Okay. Then we have 3 minus 5 to give us minus 2. 4 minus 5 will give us minus 1. 5 minus 5 will give us 0. 6 minus 5 will give us 1. 7 minus 5 will give us 2. Now the next one is, remember we are following this formula. We are following the formula given to us, okay? Now the next one is, we should square our answer. The answer we got here, we will square it. Then when you square 2, it's just like saying minus 2 times minus 2. This will cancel this. 2 times 2 will give us 4, okay? 4. Here will give us 1 times 1 will give us 1. Here will give us 0. Here will give us 1. And here will give us 4. So the next instruction, according to our formula again, is summation. We sum our value here. This is summation sign. Summation sign, okay? We sum our value. So let's sum it. 4 plus 1 will give us 5, plus this will give us 10. Now let me clean this. Okay, 7, 9, and 11. Okay, we have here 10. The next instruction, we should divide 10 with the number of population. Our number of population is 5. When we divide it, 10 divided by 5 will give us 2. Okay? So our next instruction is the square root of 2. According to our formula, the square root of 2 will give us 1.414. So let's write it here. 1.414. Okay, let's solve the second one. Okay, the second one here, we have 3, 5, 7, 9, 11. So let's calculate our mu. 3 plus 5 plus 7 plus 9 plus 11 divided by 1, 2, 3, 4, 5, okay? Divided by 5. So our answer here is 3 plus 5 plus 7 plus 9 and plus 11 divided by 5 give us equals to 7. 7 is our mu. Let's write 7. So the next one is our xi minus our mu. 3 minus 7 will give us minus 4. Here will give us minus 2. Here will give us 0. Here we have 2. And we have 4 here. Let's square it. 4 times 4 will give us 16. And here will give us 4. We have 0 here. We have 4 here. And we have 16 here also. So what's the summation here? 16 plus 4 plus 0 plus 4 plus 16. We have equals to 40 as our summation. So what's the next? According to our formula, the next one is to divide by the number of population. So 40 divided by 5 to give us 8. Then what's the square root of 8? This will give us 2.828. So write our 2.828. So now you have seen it, that the deviation here is lower than here. So we have been able to prove our point that the deviation in our first set of data is lower than the second set of data. So you have learned what standard deviation is all about. You also learned some formulas and examples too. So if you found this video helpful, please comment, like, and subscribe. Do not forget to share to your friends too.